Moving to the next question, what we are going to have is flip a fair coin twice. If the outcomes are tail head, then we get the output Y and it gets stops. If the outcomes are head head or head tail, then output is N. And if it is tail tail, we again repeat the step 1. So let us understand this with the help of a beautiful tree diagram because it is helpful in such questions. So what we have to do is we first have to toss a coin. So tossing a coin twice will give the following outcomes, correct? The 4 outcomes that we know. It is head head, head tail, tail tail, or tail head. So when the outcome is head head or head tail, we are just getting output as N. In tail head, we are getting output as Y. But whenever we are getting tail tail, again we go to step 1, which is again we have to flip the coin twice. So we'll get again 4 outcomes, that is head head, head tail, tail tail, and tail head. Again here we will get output as Y and this output will be N. And for tail tail again we will keep repeating the process. And then again tail tail, we will again flip the coin and this process keeps on going forever. Now the question is to find the probability that the output is Y. When the output is Y, whenever we are having tail head in each of the cases. So what we will do is, I will write down here what the required probability that the output of the experiment is Y. So in the first case, first trial, you see, the output is just 1 by 4 for each of the outcomes, correct? So it is just 1 by 4. Or in the second case, if we are getting again this, if we get tail tail, what we will do? We will again flip the coin. Okay. So in this case, for tail tail, the probability is 1 over 4. And again, we will get Y tail head. So again, here the probability is 1 over 4 again. Again, if we get tail tail, we will flip the coin twice. So again, we will write 1 over 4 for this tail and 1 over 4 for the previous one, correct? And for this tail head, it is 1 over 4. Continuing this process, we'll get a geometric sequence. So this is just a geometric sequence, 1 over 4, 1 over 4 square, 1 over 4 cube, and so on. And we know that sum of geometric series, infinite geometric series, is nothing but a over 1 minus r. A over 1 minus r. So a, that is the first term here, which is 1 over 4, and here we are having 1 minus r is a common ratio, which is 1 over 4. So this is nothing but 1 over 4 divided by 4 over 3. Sorry, this is going to be 3 over 4 rather, not 4 over 3. So this is 3 over 4. Simplifying, we get 1 over 3, which gives the answer as 0.33. So this is the required probability that the output will be Y. This was just based on geometric series. Now moving to the next question. The question says that two people decide to independently roll two identical dice, each with 6 faces, numbered 1 to 6. The person with the lower number wins. In case of a tie, they will roll the dice repeatedly until there is no tie. Correct? What we have to find basically the probability that one of them wins on the third trial. That means if he is winning on the third trial, the first trial has to be a tie, as well as the second trial has to be a tie only. Then only in the third trial, one of them will win. So what is the probability that it is a tie? They are rolling two dice basically, one by P and another by Q. So how many outcomes we are going to have? We will be having total 36 outcomes. When they are going to have a tie, when we have the outcomes, so tie will be only possible for these outcomes. When we have this 1, 1, 2, 2 and so on till 6, 6. So probability of getting a tie, it will be 6 divided by 36, which is 1 over 6. So probability of having not a tie between them, that is a complement 1 minus 1 over 6, that is 5 over 6. And this winning is the complement of this not tie, correct? So we can write down the required probability that one of them will win in the third try. So it is going to be equal to first tie, it is 1 over 6. Second match also tie 1 over 6. And the third match is not a tie. That means one of them is winning. That is 5 over 6. Simplifying this, we get 5 over 2 and 6 approximately equals to 0.023. So this is the required answer. Let's start with this question. It says that a bat has R red balls, V black balls, and they are all identical except for their colors. In a trial, a ball is randomly drawn from the bat, and its color is noted, and the ball is placed back into the bag along with another ball of the same color. So this means that, let's say, this is our bag, which is having a red ball, R red ball, and B black balls. If in the first draw, let's say we are drawing a red ball. So what will be the probability of drawing a red ball? It will be R over R plus B. Total number of ball is R plus B. And similarly here, for drawing a black ball, the probability is going to be B over R plus B. If the ball drawn is red, in the next step, one red ball will be extra added to this. So in the second case, what we are going to have, we will be having total R plus 1 red ball and 1 black ball. And in that, so this was our first trial. In the second trial, if the first is red, then in the second trial to get the red ball again, it will be R plus 1 over the total number of ball, which is R plus B plus 1, correct? And we will multiply it with the first trial. So this is the probability of getting red in the first and the second trial. So if once we are having black, so in the second, to get a red ball in the second trial, so this will be B over R plus B times the black ball will increase by 1, red ball will remains the same, correct? This is what we will get. Now if we add, so probability that the second ball is red in the second trial, we will have to add both of the cases. Either can happen. So what we are going to get, R times R plus 1 over R plus, this will be R plus B plus 1 times R plus B, or it can be first black then red. So it will be B times R and again R plus B, R plus B plus R times R plus 1 plus RB over R plus B times R plus B plus 1. Now let us simplify it further. We can take R common in the numerator. What we will get? We'll get R plus 1 plus B. And in the denominator, we have R plus B, R plus B plus 1. So again, these two gets cancelled. So we get the probability that we will get a red ball in the second trial as R over R plus B. In the first trial also, we are getting R over R plus B. Now, I will just write what happens in the third trial. So probability that we will get a red ball in the third trial, in the similar manner, we will get R over R plus B. And in the fourth trial also, we are going to get the same thing, which is R over R plus B. Adding extra ball does not change the probability. So this was one interesting question. And this is the correct answer, R over R plus B. You can check this third or fourth cases as well. Now moving to the next question, which is A and B, with two event in a probability space, we have been given the probability of A as 0.3, probability of B as 0.4, and probability of A intersection B as 0.12. We have to check which of the following options are correct. So first, whether they are independent or not. So we know that for the first condition, if A and B are independent, then probability of A times probability of B should be equals to the intersection. So this is given as 0.3, 0.4, and this is given as 0.12. So yes, they are independent. Check the second option. Probability of A given B. The conditional probability, we know the definition. It is probability of intersection over the probability of B. So intersection is probability is 0.14, B is 0.4. Simplifying, we get 0.3. So yes, the second is also correct. Moving to the third option, it is given that probability of A complement given B complement. So again, using the same definition, this can be probability of A complement intersection B complement over probability of B complement. This is nothing but probability of A union B complement from De Morgan's theorem, and this is 1 minus probability of B. So again, we can write this as 1 minus probability of A union B and 1 minus probability of B. So what we are going to get? 1 minus probability of union. Okay, so union probability is not given. So to get the union probability, we can use inclusion exclusion principle, that is probability of A plus B minus the intersection. So this is 0.7 minus 0.12. What we get is 0.58. So 1 minus 0.58 divided by 1 minus probability of B is 0.4. Simplifying this, what we get 0.42 over 0.6, which gives the answer at 0.7. So yes, third option is also correct. And in the next, we have been asked to check what is the probability of A complement intersection B complement. So this is nothing, using De Morgan's law, we can write this as A union B complement, which is nothing but probability 1 minus A union B. 1 minus A union B, we already got as 0.58. So this comes out to be 0.4 true. Again, fourth option is also true. So all the options are correct. Hope you got the